So basically, play till here, and now we go forward from here. So the next thing we're going to do is it's basically power. Okay. Now, power is basically defined as work done or energy per unit charge. Okay. The SI units for power are watts or joules per second, or basically it is a scalar quantity. Now power itself, has three different formulas. So one of those are energy over time. You could also write work done over time. But there is also a third one, and that would be a small derivation. So when you open up work, because work is force times displacement and it's divided by time. So you might see here the displacement or time is basically velocity, which means when you add it there, it's gonna be power equals to force times velocity. Is it clear, everybody?
Yes.
Okay, so do remember that. This is a very important formula. Mostly he's going to ask you questions from this. Okay, now let's try and do an example. The example you're going to understand what I basically mean. It says an escalator is 60-meter long and lifts passengers through a vertical height of 30 meters. Then says power needed to overcome friction is 2.0 kilowatt. Okay, so considering each passenger is 60 kg, so it says how much power is required to carry 20 passengers to the top if escalator moves at 0.75 meters per second. Is it clear, everybody? That's the question. Now, so when you look at the how it's basically working is, what it says is that basically this is the escalator. It says this height is 30 meter, the vertical one, and basically this whole thing is 60-meter long. So the people are moving, it's moving at a speed of 0.75 meters per second. Naturally, there's going to be a theta here, you gotta remember. And now we need to find the total power through which the people are going to go from bottom to the top. Also, it is going to overcome the friction. Okay. Now, so what you're going to do is, first of all, the weight of these 60 people are going to act downwards. Which means one component of the weight, because it is a slope, one component is going to be down the slope, and one component is going to be the perpendicular one, and this is theta. Which means this component is W sine and theta. Is it clear, everybody? So the escalator needs to overcome this force W sine theta. Also, it needs to overcome the force of the friction. So what we need to do is we need to first find the the force. Okay. Now let's try to do this here. So W, let's try to find sine theta first. So sine theta is generally perpendicular over hypotenuse. So the perpendicular in this is 30 and the hypotenuse is 60. I'm just going to keep it like that. Okay. Aisha, Mad, Javedi, Aman, is it clear?
Yes.
Now let's check this out. Because the equation for force is W sine theta, and W is basically mg sine theta. So the mass of the passengers was basically 60 kg, and there were 20 passengers. So that would be total mass. That's multiplied with 9.81 to find the weight and the sine theta. And the sine theta, I intentionally left it like this because I just want to replace sine theta as 30 over 60. Got it? I'm going to use
Sorry, can you repeat it?
Yes. You see, Aisha, there were 20 people of 60 kg, right?
Yes.
So the total mass would be how much then?
1200.
1200, right? Which is 60 times 20. So we got the mass. If I want to find the weight, shouldn't I just multiply it by 9.81 then? Got it?
Yes.
And then I have to multiply sine theta. The sine theta value is basically 30 over 60, which is the hypotenuse. So instead of writing sine theta, can I write 60? You can also find theta and then put it. So that's also fine. Is it clear?
Yes.
So this is basically, if you need to visualize, this whole thing is mass, this is g, and this is sine theta. Do you see now? Okay. So now with your calculator, you can just simply find this and like, okay, 60 times 20. Oopsie, 60 times 20 times 9.81 times 30 over 60. So this is going to be, the force is going to come out as 5 886 newtons. This is the force needed to raise the passengers from bottom to top. Okay, force needed to raise passengers. Now we need to find the power. Okay, so power of passengers that we need is basically force times velocity. The force was 586 and the velocity was 0.75 at which it is traveling. So the power, wait a second. So 586 multiplied by 0.75 is 4414.5. Okay. So we get 4414.5, which we can write it as 4.4 kilowatt. All right. Now it says what is the total power that is needed. So power total is basically the power that is needed to raise passengers plus power to overcome friction. So the power needed to raise passengers was 4.4 kilowatt and the power needed to overcome friction was 2. So the total power needed is 6.4 kilowatt. Is it clear? And that would be the answer. Let me know if you do not understand this. Okay.
इसमें देखो तुम्हारे 3 नाम आए हैं और तुम्हारा एक नंबर डिलीट है.
Is it clear, everybody? Aman and Javeria and
Yes, sir.
Ahmad, Aisha. Okay. Okay.
चलो हम बात
Now, so now we are going to go towards second please. Okay, so now let's go to the next question. Okay, now this question is a tricky one and I just want to show you why certain questions that we have to deal with in this chapter requires a bit more understanding of physics. Okay, now please check how we do this so you guys actually are aware that okay, this is how we need to think when we're doing these questions. So a question says a wind turbine blades that sweep an area of 2000 meters square. It converts power available in the wind to electrical power with efficiency of 50%. So then it says what is the electrical power generated if wind speed is 10 meters per second and density of air is 1.3 kg per meter cube. I think before we do this, let's just define efficiency quickly so that before we go to this question, we are basically ready for this final question. Okay, now let me just tell you this. Let's quickly define efficiency. So efficiency is total input the two prime formulas are that efficiency is total input, which is equal to useful output plus some wasted. Okay, wasted power, wasted energy, that could be same. The symbol for efficiency is this N thing. It is called eta, by the way, and eta is basically given by, it's a ratio of useful output over total input. If you want to find percentage efficiency, then it is useful output over total input, and that's 100%. Because it is the ratio of the same quantity, so which means that, just remember this, ratio of same quantities do not have units, because units cancel out above and below. Is it clear, everybody?
Yes.
All right. Now let's try that question that I'm talking about. Okay. So sometimes they give you a difficult question, and that's how it is, and they really want to test everything that you know about mechanics. So let's look at this one. So basically what it's saying is that there is a wind turbine. Generally that looks like this. And it says that these blades, when they move, right, in this circle, the area that it sweeps is 2000 meters square. It's big blades, right? The wind is passing through these blades at 10 meters per second, and it only converts like 50% of the energy that the wind has, and its density as well. Okay. Now, first of all, I would like to understand that what exactly what is the input energy? So because wind is, moving, do you know which energy it should have?
Kinetic.
Kinetic. So which means kinetic energy of wind should be given by half times m times v square. Interestingly, you see, we have the velocity and we have the, yeah, and we do not have the mass, but we do have the density. So from density, we can find this mass, and we know density is given by mass over volume. If I look at this formula, then you might think, okay, so we need mass, but we don't have the volume, but we have the area, right? So, which means that itself, the volume can be written as area times the length. Can I do that, please? Do you guys agree what I'm saying?
Yes.
Now, from this, it's funny, really. So, basically, I needed mass, and to find the mass, I need density, which I have, and now I don't have volume, but I know I have area, so volume is given by area times length. But now I don't have the length, right? So, what do I do? So, because it is moving at velocity, and the velocity is basically, if you look at it, it's 10 meters per second. What does 10 meters per second signify? It basically tells us that because velocity is displacement over time, so the displacement, which is actually the length the air moves, would be 10 meters per second in 1 second would be equal to 10 meters. So it means every second the air moves 10 meters length. Is it clear?
So you took the speed as length?
No. I said how much distance or length the air is going to cover in 1 second. Do you understand? So, because you see, I'll do it again from here. I want this displacement, right? So, displacement, which is length, is velocity into time. You agree? So,
Yes.
for only 1 second, can I say its length would be, the speed is 10, and in 1 second, the length would be 10 meters, because speed means 10 meters moved in a second. Understood?
Yes.
And this is the length it covers in 1 second. Can I say that? Okay. Now that I have reached to that, I can put it back. So the volume, can I write volume as 2000 is the area. So how much volume of air passes in 1 second would be, if I multiply 10, so it would be 20,000 meter cube. Do you understand? So the volume
Yes.
of air that basically passes through, all this volume that passes through in 1 second would be 20,000. Okay, now we can go back. Now mass is density times volume. Density is 1.3 and the volume is 20,000. So it means in just 1 second, it is going to about 26,000 kg of air would pass through the plates. Understood? So now going in reverse direction, right? And then how much energy in a second that would cause? So the energy of air would be 26,000 multiplied by 10 whole square. And that's going to be 1300,000 joules. In 10 minutes, please rejoin, okay? Okay, Aman, Hamad, and Javeri and Aisha, you guys understand up till now?
Yes.
Okay. So, the power of air would be energy over time. The energy of air in 1 second was this, so I'm going to divide by 1 seconds. So this is going to be 13,000, 1300,000 watt is going to be the energy, sorry, the power that the air gives. Okay, now we need to find the electrical power generated, but this time we know that efficiency of this is only 50%, which means that efficiency, which is given by output over input times 100%, is the percentage efficiency. What is that? That is 50%. The output was what we need to find, but the input was 1300000 times 100%. So now let's try and find the output. So output will be 50% divided by 100 multiplied by 1300000. So I'm gonna find this using my calculator. So 50 divided by 100 is 0.5 times 1300000, and that's gonna be 650,000 watts. Is it clear? So the reason why we're doing this question is because I want you to understand that every question, no matter how complex it is, if you go from, you know, the prime equation, which is half mv square, and you don't know exactly where to get m, but you scan through the other quantities and write their formulas, you will get to the end point from where you can start solving that problem. Is it clear?
Yes.
Okay, please write this down. And you will find numerous questions like these, and definitely it will take some time. And interestingly, this question is not a question from paper 2. This question is from paper 1, which is the MCQ paper. Okay.
This is paper 1.
That is paper 1. So you might be wondering, how much time do we need to solve this? Okay. You know? Exactly.
Yes, sir. How will I have the time?
Yes. So what happens is they know exactly that students will feel, difficulty. So generally you leave these questions to the end, and some questions will just take like a split of a second for you to answer, and some questions might take 10 minutes to answer. So you have to manage time. You don't have to spend a lot of time on a question which basically is a long one. So you keep on doing the paper, just skip the ones which you feel that okay, it will take time, and at the end when you have enough time you can think about it. Understood? Never ever get stuck on a question and sit there. Always skip to, this is a technique, because the thing is that these questions might eat up all the time, and other questions are left which could have been solved. So always do the easy ones first, and medium ones, and then the hard ones at the end. Is it clear?
Yes.
Frankly speaking, paper 1 is the hardest paper, I think, but you will get it. You'll understand when we start solving the papers, you'll see. Okay. Alright, should I move on now? If you guys have any questions, please let me know. Now, let's move forward. See. So now we're going to do relationship of work done with pressure by a gas. So this is a small derivation that you guys need to know. So suppose we have a syringe or something like that. So the syringe has a plunger, which is basically looks like this. So you apply a force on this, so the plunger is pushed inside, and there is of course gas in. So when the plunger is moved in, basically you cause it to move from a distance, a change in x like this. It moves like that, right? So naturally the plunger will have some area, and the area stays the same, but the distance changes, so the volume reduces. Now what we have learned is that we know that work is force times the displacement, and in this one the force has caused a change in length, which is delta x. Okay, so this is our first equation. And we also know that pressure is force over area, so that's 2, and the force is pressure times area. We can write it like this. Okay. So then what you're going to do is just substitute equation 1 in 2. So when you substitute this, you see that work done will be equal to pressure times area instead of force, and then change in x. Now itself, you see that change in volume would be equal to the area times change in x. How do I know this is change in volume? Because initially I had this whole volume. So say this is Vf, and then when I push the cylinder in, push the whole thing in, so now I have this much volume left. So that was the final volume, and this was the initial volume. So the change in volume is caused by final, like initial minus final, larger than this. So that's how it has caused change in volume. So what I'm going to do is I'm going to replace this whole thing with this thing. So then work done will be equal to pressure times change in volume. This basically is final volume minus initial volume, or vice versa, it doesn't really matter. This is the pressure change in volume, and that's work done. So you guys need to remember this, and you have to derive this up till this point, okay? The only thing to remember in this is, I'm going to write it down here. Note that this equation is only valid for constant pressure. So it means that it will only work when you have no change in pressure, but your volume is changing. So you gotta remember that, okay? And you can see from the equation itself that pressure is the same, but the volume is changing. That is doing some work. Is it clear? Okay. Yes, Maz. नहीं अभी मैं करने लगा मैसेज. Yes. Okay. Okay. All right. मैं कर. Okay. So now let's just quickly do one more question, and then we're really done with this chapter actually. So question says the volume of gas in a syringe is 2.0 centimeter cube at room temperature and atmospheric pressure is 1.101 kilopascals. It says what is the work done by gas when it is heated by expanding to 6.0 centimeter cube. All right. So now work done will be pressure times change in volume. You know the pressure is 1.1 and 10 raised to power 3 would be the kilopascal one. And the change in volume is going to be basically 4. 6 minus 2 is 4. But see, this is in centimeter cube. So how do we change centimeter cube? So remember, 1 meter has 0. Or let's say 10 raised to power minus 2 centimeter. Okay. If I want to go to meter cube, then what I'm going to do is I'm going to cube this whole thing. This will be 1 meter cube will be equal to 10 raised to power minus 6 centimeter cube, because 4 centimeter, it's 4 centimeter cube, so I can replace it 4 centimeter. My god, I didn't do it correctly. This was 10 raised to minus 2 meter is 1. So 1 centimeter cube is basically 10 raised to minus 6 meter cube. So that's going to be, I'm going to replace this with this. So that's how I go from centimeter to meter. And then I will get 0.404 joules, which is just 404 millijoules. Is it clear, everybody? Any questions, please let me know. I hope that's clear. Okay, so that would be basically all. This chapter is finished, and tomorrow we're going to do a worksheet. All right, together then. All right, bye, have a nice day.